Hello there. Welcome to the Strength of Materials video lectures. In this video lectures, we will try to learn the relationship between the stress and strain when the object is going to be subjected to orthogonal normal stresses, particularly for the 3D objects. In the last video lectures, we have seen when a plane figure is going to be subjected to the two mutual perpendicular stresses. And from this one, what we have calculated? We have calculated the stress-strain relationship by using the stress terminologies, right, and strain terminologies. There we can see sigma 1, sigma 2 and sigma 3. These are the stresses in x, y, z directions respectively. There we can see that three-dimensional objects I have taken. From this one there we can see x, y and z coordinates, that's going to be the origin suppose. Then what happened? The loads, that means stresses are going to be generating, that the sigma 1 and the sigma 1 over here, sorry. So these are going to be, the load is acting in the x direction, sigma 2 is going to be acting in the y direction, sigma 3 is going to be acting in the z direction. And similarly, we do have epsilon 1, epsilon 2 and epsilon 3. These are going to be the strains developing due to the stress in the body, that is in the x direction, y direction and z direction respectively. Right? And similarly, a few more terminologies also we are using, that's going to be epsilon L. This is indicating the longitudinal strain. Next, epsilon T is indicating the lateral strain, and similarly the mu terminology we are using, that is the Poisson's ratio, is equal to the lateral strain by the linear strain. By using these terminologies, we are trying to find out the relationship between the stress as well as the strain. And what we are going to do first? We know that the member is going to be subjected to the three mutual perpendicular stresses. So then I am going to be applying the principle of superposition. It means I am going to be calculating the strain at individual directions. Suppose that is the x direction 1, y direction 2 and z direction 3. So these three directions individually I am going to be considering by considering the individual stresses, and then I can calculate the total strain and stress relationship. To apply the principle of superposition, already we discussed how the process we are going to be adopting here. There we can see initially that's going to be, the object is going to be subjected to the stresses in x direction, individually I have taken, and secondly in the y direction, and the third condition is going to be in the z direction. Now I will try to find out the individual strains respective directions. As we have seen in the previous, the terminologies, that's one, I am going to be taking in the one direction. It means in the x direction strain I am going to be considering, that I am going to be taking EL, that means epsilon L is going to be indicating the longitudinal strain. There we can see the load is going to be applied in this direction. We assume that the material is going to be started to deform in this direction, right? So then that is equal to, we do have, that's going to be sigma 1 by E I am going to be considering. This is the stress and strain relationship we need to be calculated. That's why we are using the sigma 1 by E. E is going to be nothing but your Young's modulus of the material, and that is in the direction of the 1 I am going to be taking. And similarly, there is a second direction and the third direction also, the material deformation is going to be occurring. So that I am going to be taking epsilon T2 direction, because this is indicating the lateral strain, that is equal to, what is the formula we do have? That's going to be minus mu into sigma 1 by E. Because of these stresses, the material in the third direction, that is the second and third direction, are going to be reducing or maybe elongating. And similarly, the strain in the third direction I am going to be taking, that is the lateral strain, is equal to the formula minus mu into sigma 1 by E. Right? And this is going to be the strain when the member is going to be subjected to the single stress. And similarly, when the member is going to be subjected to the second direction stresses. So then in this case what will happen? Now it will become, in the y direction will become the longitudinal strain. So that I am going to be taking epsilon L2 I am going to be taking, because the stress is acting in the y direction. So whatever the dimension changes is occur in the y direction or second direction, we can say that's going to be your linear strain. Remaining two directions, 1 and 3, will become the lateral strain. So what is the formula? This is going to be the stress is equal to, that is the strain in the longitudinal direction is equal to strain, that is the sigma 2 by E. And similarly, in the another two directions we need to be taken. That's going to be the lateral strain in the direction 1 is equal to minus mu into sigma 2 by E. There we can see this is the magnitude of the strain that we are going to be getting in the transverse direction. Now 1 will become the transverse or lateral direction. And similarly, epsilon T3 is equal to minus mu into sigma 2 by E. Because this strain in the third direction is existed because of the load in the direction of the 2. And similarly, I am applying for the third direction. That's going to be, now in this case, the z direction is the stress is going to be acting. The changing the dimensions in that direction we are going to be considered as the longitudinal strain. Remaining 1 and 2 directions we are called lateral strain. That's going to be epsilon 3 is equal to sigma 3 by E. And similarly, then epsilon T1 is the lateral strain is equal to minus mu into sigma 3 by E. And similarly, we are going to be taking epsilon T2 is equal to minus mu into sigma 3 by E. So this way we have calculated the individual strains in their respective directions. Now what we are going to do, we are going to be applying the principle of superposition. So then how we are going to be applying the simple, that means principle of superpositions that in the directions of the x directions. So there we can see epsilon 1 is going to be the strain in the x direction. That's due to the orthogonal normal stresses acting on that member. So there we can see epsilon 1 means that is in the direction of the x direction. How many terminologies is belongs to here to the x direction? There we can see epsilon, that means L, that is longitudinal strain, lateral strain, and the lateral strain in the direction of the 1. This is generated due to the stress in the one direction. This is generated, the strain is generated because of the stress in the second direction. This is in the third direction. So that I am going to be taking L1 epsilon T1 plus epsilon T2. So that equations I am going to be substituting sigma 1 by E plus here that's going to be, and I am going to be taking minus mu into sigma 2 by E, and here that's going to be minus mu into sigma 3 by E. So there we can see this is generated because of the stress in the direction 1, and this strain is generated because of the lateral strain is generated because of the stress 2 and 3. And similarly, this is going to be your epsilon 1, I can say. So this is going to be the strain in the direction. Similarly, epsilon 2, if I am going to be taking, it is very clear that the strain in the y direction. Similarly, I am going to be writing epsilon 2 plus epsilon T2, that means epsilon T3, longitudinal strain, lateral strain, and lateral strain in the second and third directions. Right? So then what will happen here? So that epsilon 2 is equal to, this is going to be sigma 2 by E. I am going to be writing epsilon 2 is nothing but that is generating the strain because of the load 1 in the direction. That is going to be mu into sigma 1 by E, and similarly the lateral strain because of the third direction. That's I am going to be writing mu into sigma 3 by E. So there we can see now we got the strain in the direction of your second direction. Now I am going to be taking in the third direction. So that's I am going to be writing over here epsilon 3 is equal to epsilon L3, that means longitudinal strain. This is going to be the strain in the due to the direction, the stress direction in the 1, and this is going to be the second direction strain. So there we can see this is the 3 and this is going to be the 3 I am going to be taking, right? So then what we are going to be getting here? So that's epsilon 3 is equal to, this is going to be sigma 3 by E minus mu into sigma 1 by E minus this is going to be mu into sigma 2 by E, right? So this way we are going to be calculating the stress in the x direction, strain in the one direction, second direction, and third direction. So this is the mathematical model will helpful to identify the stress strain relationship between of the 3D objects when it is going to be subjected to the orthogonal normal stresses. And with this one, we can calculate either strain we can calculate, or we can calculate the stress, or we can calculate the Poisson's ratio. That depends on the availability of the data. I hope you are able to understand the concept of this mathematical model, how we developed. Okay, thank you.